Hello and welcome to my channel. In this video, we are going to learn about selection sort. It is the simplest in-place comparison sorting algorithm. As the name indicates, it first finds the smallest element from the unsorted part of the array and places it at the correct index in the sorted part. So now let's understand the steps to code selection sort algorithm. As you can see, this array is unsorted initially, and to begin with, the first step will be to set the first element of this unsorted array as the minimum, which is 8, and this becomes my minimum. In the next step, we are going to compare this 8, which is the minimum element, with the second element in the array. That means we are now checking if 5 is less than 8. As this becomes true, we are going to set 5 as the new minimum element. And now we move on to the third element in the array, which is 7. So now we check 7 with the minimum element that we got in the last step. As this is false, we go to the next number, 12 less than 5. This is also false. And here we have reached the end of the array and the element is 2. So we check 2 less than 5, condition becomes true, and 2 becomes the minimum element. So all these steps are repeated till we reach the end of the array. So after this iteration, you can see that I've got the minimum element, which is 2. As we are going to sort this array in ascending order, once we've got this number, we are going to swap the value with the first element that we assumed to be the minimum. So here we will get 2 and this is going to be 8. Now in the next iteration, we are going to start with this number to be the minimum element because this part will be considered as the sorted part of the array. And now we will be moving on with the elements in the unsorted part. So in the next iteration, it is going to be 5 and then we keep on checking for the minimum element. And the indexing for every iteration will start from the first element in the unsorted part. As I said, in the next iteration, I begin with 5. And then we are going to repeat all the previous steps until all the elements are placed at their correct places and the entire array is sorted. Here I have coded selection sort algorithm in C++ and I have used pythontutor.com to explain the step-by-step execution of this function. And on the right hand side, I'm using this VisuAlgo to show the visualization of all the steps. So let's get started. This is the selection sort function that I have written and the function's prototype is void. This function accepts two arguments, ARR and size. ARR is the array and size contains the number of elements in the array. I've also defined a variable min_index. This is going to hold the index of the minimum element of the array. So this is the first loop that I've written. I starts from 0 and goes till it becomes less than size minus 1. In the next step, as we know that the array is unsorted, so I'm going to assume that the first element of this unsorted array is the minimum element. Next is the jth loop. This is the inner loop. As we are going to compare with every element in one pass, so I've written this loop which will start from the next value of I. So that means you can see for 29, I'm going to compare it with 10. That's the reason j has been initialized with I plus 1 and it goes till it becomes less than size. So let's start the comparison. In the first step, we compare the value at jth index as j is 1. So we are comparing if 10 is less than 29 as the condition becomes true. So the min index variable is now going to hold the value of j as 10 becomes the new minimum element. So now we are going to compare 14 and 10. As 14 less than 10 condition becomes false, so 10 remains to be the minimum element here. Now we compare 10 and 37. Again, 10 is the minimum element. And in the next step, we are going to compare 10 and 14. Again, 10 is the smallest element. So after one complete iteration of this jth loop, you can see that 10 has come out to be the smallest element from the right hand side, which is the unsorted part of the array. And now we are going to swap it with 29. Once this is done, 10 is in the sorted part of the array now. And we move with the next pass. Here I becomes 1 and from the unsorted part of the array. That means this area with all the elements in blue bars will be the unsorted part, and we get its first element as the minimum element. So we are going to assign the index of 29 to min index variable, and we start with the j loop. Here j starts with the next value of I, which is going to be the number 14. We compare 29 and 14. As 14 is less than 29 and the condition here becomes true, so the min index variable is now going to hold the index of 14. Next, we compare with the value 37, and here we can see 14 is less than 37, so there will be no assigning of value to min index variable. And in the next step, we are going to check 14 and 14. 14 on the right hand side is not smaller than the 14 value in the red bar, so this condition is again false, and we are done with all the iteration of this jth loop. And here we are going to swap 29 and 14, so 14 now becomes sorted, and there are two elements in the sorted part of the array, which is 10 and 14. And on the right hand side we have this unsorted part. So let's continue with the next iteration. Now I is 2, and here 29 again is the value considered to be the smallest element in this unsorted part, and we assign its index to min index variable. We start with the j loop iterations, in which we are going to compare 29 with the next value, which is 37. 37 less than 29 condition becomes false. So in this, we are going to just leave the assignment of min index, and we start comparing 29 and 14. 14 less than 29 condition becomes a true, and the index of 14 is now assigned to min index variable. And then we can see that all the iterations of j loop are over. So we move on to the last step, which is the swapping of 29 and 14. And now 14 is at its correct place. We still have few elements on the right hand side, which is the unsorted part. So min index now will get 37. We start with the j loop, where we compare 37 with 29. 29 less than 37 becomes true. That means the last index here of 29 is assigned to the min index variable. And we can see that the j loop is now over, and we are at the swapping statement, in which we are going to swap 29 and 37, and 29 is now in the sorted part of the array, and there's only one element, which is 37, and I has completed all its iterations, and the array on the right hand side you can see is sorted. So now that we have understood the algorithm and the code in C++, we are going to talk about the space complexity of selection sort algorithm. As I used only one variable, which was taking care of the minimum element in this unsorted array. So in terms of space complexity, it is optimal, as the memory requirements remain same for any number of elements. So this is going to be one variable always for any number of inputs. So the space complexity of selection sort algorithm is O of 1. The time complexity for selection sort algorithm remains same in every case. The best case occurs when the array is sorted. The average case is when the elements are in mixed order. That means neither ascending nor descending. And the worst case will be if you want to sort the array in ascending, but the array is in descending order. Or let's say your requirement is to sort the array in descending order, but the array is available in ascending order. So in all these cases, the time complexity for this algorithm is O of n square. In every step, we have to just find the smallest element, which is not possible until we reach the end of the array. So that's the reason for all these cases, the time complexity remains same. So let's see some pros and cons of selection sort algorithm. This algorithm works well on small sized arrays. It is good to use when memory is limited, and this algorithm, as we have already seen, is making very less number of swappings. The cons of selection sort algorithm is that it is one of the slowest sorting algorithm. It has a poor efficiency when it comes to sorting large quantities of data. Let's know when we can actually use selection sort algorithm. So when stability is not important. Stability is when any two equal elements in the original and sorted list remain the same. So this is not at all required here. When the list is small and swapping two elements is a costly operation, and when the memory space is limited. So under all these circumstances, you can apply selection sort algorithm. Thank you so much for watching this video. If you like the video, please click the like button. Subscribe to my channel for more videos on algorithms. Till then, keep working with smile.